Good, eh? Welcome back to the lab on this beautiful sunny day here. We've got some holidays, got some time off. I've got, you know, a beautiful element in my possession. Got my sunglasses on, sunscreen on. Bloody hell, all right, let's get into it. This is our sample of rhodium. Chances are you haven't really heard very much about rhodium, and if you have heard about rhodium, you probably associate it with one thing, and that's cost. Rhodium is one of the rarest elements in the Earth's crust. Because of that, and because it's actually useful, it has a very high price. This sample, actually, it's less than half a gram. It's 0.4 of a gram, and this cost me about 250 USD for this sample, which actually I thought was a reasonable price. I've seen it go for a lot more than that. Obviously, the price per gram decreases if you get, say, a 10 gram lump of rhodium, but that's a lot of money. It is nice to look at. I don't think it looks any different than a lot of the other metals around it, like iridium or platinum. You probably couldn't really tell the difference by eye, but none of those other elements are particularly cheap anyway. The chemistry we're going to be doing is called the Rhodium Rainbow. It comes from one of my favorite journals to do chemistry from, the Journal of Chemistry Education. If a synthesis is designed to be done by an undergraduate in like a 3-hour period, I have a reasonable chance of successfully doing it given no time limit. Now, as I've just explained, what most people think of when they think of rhodium is expensive. So why would you do an undergraduate practical with rhodium, one of the most expensive metals you can buy? This is obviously dismissed away in the paper. They don't use very much rhodium in this practical. They just collect the rhodium waste and basically recover all the rhodium. But something funny did happen after this paper was published. So the price of rhodium when this paper is published is $82 a gram. Within a year, the price of rhodium has gone to $400 a gram. Yet somehow it still continues to rise, and it hits a maximum of $934 a gram in April of 2021. So in just over 2 years, that is a 1,100% increase in price. People on Reddit really loved flexing their rhodium samples at the time. And since then, the price has decreased and we're kind of back to normal rhodium prices again. And I know this is not an economics channel, but when you see something like this for an element, I think it's really interesting because there has to be a sort of supply and demand thing that goes on that virtually no one in the world is aware of. The use of rhodium is in catalytic converters, and that's basically about it. I saw figures of about 85% of all rhodium goes into catalytic converters. On the supply side, rhodium is one of the rarest elements, as I've said, and really only a couple places in the world mine it. Most rhodium comes from mines in South Africa, and because of COVID, all those mines shut down, and there was just really no supply of rhodium for a little while. Some rhodium also comes out of Russia, but really worldwide, only about 30 tons of rhodium is produced. What's interesting actually out of that 30 tons is a third of that is from recycling. The catalytic converter doesn't really consume the rhodium too much. You can just recycle old catalytic converters to get the rhodium out to make new catalytic converters. Because of course, it's so good because every country can recycle their own catalytic converters and have a supply, and they don't have to rely on a couple of mines in South Africa which can just close at any time. It's hard to work out why the price has fallen so much recently. I've seen online some people speculating because there's new EU regulations against diesel vehicles. Going into the future, there's going to be a lot less diesel vehicles. So electric vehicles don't need catalytic converters, so you don't actually need rhodium to make an electric vehicle. So maybe there'll be less demand for rhodium in the future, and we can go back to putting it in jewellery and stuff, because it looks really nice in jewellery, but I think it's just too expensive. We can just grind up all their catalytic converters and wear the rhodium as rings and shit. In saying that though, the same places that mine the rhodium also mine iridium, and we mine even less iridium globally. The price of iridium has not dropped after the huge spike because of all South Africa shut down or whatever. So potentially for a first time in quite a while, or maybe even ever, the iridium price is higher than rhodium. So rhodium's not even the most expensive metal anymore, which is funny. Okay, all of that nonsense aside, forget about supply and demand. We have 0.4 grams of rhodium metal, and we want to turn it into the rhodium rainbow. So how do we do that? Looking up references, we can make rhodium tetraacetate from rhodium hydroxide, I guess, and we just got to get the rhodium into solution. Rhodium is unsurprisingly, a very unreactive metal. It's a bit like iridium, a bit like platinum, a bit like gold. It doesn't even really react with aqua regia, so we can't just dissolve it up like we would gold or platinum. Instead, we've got to bring out the big guns again. I think boiling concentrated sulfuric acid is probably the way to go. There's a really nice video done by Cody's lab. As usual, he had some rhodium powder and he dissolved that up with sodium bisulfate. Because our rhodium is in a bead, like a 0.4 gram bead rather than as a powder, it's going to be difficult to dissolve it up in a melt like that because it's so thick. We kind of do want the concentrated sulfuric acid with a bit of stirring or just like boiling action so that we can try and dissolve off the metal. There is a 2016 paper about making rhodium sulfate from rhodium and sulfuric acid, and they used a pressure vessel and sulfuric acid, concentrated sulfuric acid at 400 degrees C. I mean, it's kind of tempting because it would be a scientifically interesting way to die screaming. We might try and step back a little and do just boiling, refluxing sulfuric acid. We don't have to dissolve the whole lump, but we just want to dissolve at least a few 100 milligrams. Well, we've only got 400 milligrams really in there. Maybe a quarter of it would be great. I'm not sure what kind of color we're going, but I think if we take this solution and then put it into water, it should precipitate out rhodium hydroxide. And then we can go into the tetraacetate and then into the rainbow. That's what I think will happen. It's a bit hard to be certain of these things, but that's what we're going to attempt to do. We're turning an expensive metal into sludge using drain cleaner because it might make some cool colors. That's all right. Here is our rhodium. I guess the first thing to do is weigh it, but my milligram scales have appeared to cark it. I changed the batteries and everything. Time to get another one. I should really treat my scales better. Actually, you know what? On camera, I'll do what... I don't know who in the comments keeps asking me to do this, but I understand that this is a protective layer that you're meant to take off as soon as you get the scale, but it was protecting it. Here you go. This is for the one guy that comments that I should take this off. I hope that was enjoyable for you. Anyway, it's not sticky now. Look at that. Beautiful. Anyway, I very much doubt we would have been given any more or any less than exactly the specified amount, but it's good to weigh exactly how big this lump is so that if we don't dissolve it all, we can re-weigh it later and see how much we've actually have dissolved off it. Oh. I mean, my scale is not too good. Or maybe the store has been extremely generous to us, but let's go with that. On the side, get up all these little bits. This is, once again, just drain cleaner sulfuric acid, concentrated sulfuric acid. Make sure I've actually got proper eyewear on and not sunglasses. This stuff is nasty. This is the same tactic we used for the niobium metal. We dissolved up some niobium metal a little while ago, and that's a very unreactive metal. That is more so unreactive because it's got a very inert oxide layer. Rhodium is just unreactive itself. It doesn't even form an oxide layer, really. It's just an inert metal. It doesn't want to react at all. Oh, one thing I just noticed is this sulfuric acid is pretty dirty. I mean, it's usually pretty dirty, but it's got a few fucking floaties in it now. A lot of white solid down the bottom. Yeah, it's that's coming from the bloody bottle. I think the plastic is deteriorating inside here, as you might expect from long-term contact with sulfuric acid, so should get it out of there. Look, this is horrific grade sulfuric acid, but everything in here, every contaminant is so chemically different than rhodium ions that I'm sure will just be able to purify out the rhodium anyway. Even though this is absolute dirt grade sulfuric acid, we're just going to go ahead and do it. I'm sure it'll actually self-clean in a way, because once this gets to boiling temperature, it'll be, it'll just get rid of every organic contaminant in there anyway. This is a high temperature reaction, so we've got a high temperature stir bar. It's a high temperature magnet in some glass rather than Teflon, so it can survive the horrific temperatures and acidity of the solution. We won't be stirring at high speeds or anything because we don't want to grate the glass on glass and erode the flask. Yeah, just having a stir bar in there so we can stir if needed, and even just gently would be really nice. And then the last step is our rhodium into solution. Great. So we'll get this heating. We've got to set up a condenser too, but yeah, let's get this heating. Alright, it's heating up slowly. There's no reaction, you can't really see too much in there anyway, but the iridium, I'm calling it iridium, it's definitely rhodium. It does nothing with the acid at room temperature. There's no reaction at all, but we'll let this heat up, get to boiling. It might take a long while. I have no idea what color it's going to go. It might go more of a brown, might go browny yellow as per usual. It might go like a green or a red. I genuinely don't know, but we will see. We've got the air pump going, by the way, as well, just so got an air condenser, because we don't need water flowing through here, because this is quite hot, and the temperature gradient, and for safety. So this is a very similar setup which we use for the niobium to dissolve, and it only took a couple of hours really for the niobium to dissolve. I have no idea how long we're going to need to get appreciable amounts of rhodium into solution, or if we're even going to be able to tell when it works. A lot of unknowns. One thing we do have is enthusiasm. So we're going into this montage with enthusiasm, and hopefully things work out okay and safe. Because fuck me, it's scary every time. This is sulfuric acid. Frightening stuff. Look at that. Yeah. Everything's okay. Alrighty, and it's had about 7 to 8 hours of reflux. That was split between 2 days, kind of 3 hours and then 4 hours. And it's nearly cooled down to room temperature now. Where is it at? Oh, still 50 degrees. It's been cooling down for about half an hour. It takes a long time to cool down from like over 300 degrees. But hey, look at that. Look at that colour. It's very nice. We've got some residue around the sides, and yeah, a definite orange colour. Fantastic. I wasn't entirely sure it would work, but here we are. Definitely got some rhodium in solution. There's definitely still a lump of rhodium in there. So I'll see if I can laser it. There. It's good to know that we can dissolve up the lump of rhodium in there. And that's why I put in just that lump in. I didn't put in the last little bits of... There's some little faint bits in there. I really wanted to see whether the lump would dissolve at an appreciable rate at all, not just these little tiny flecks. Plus, I gotta keep some rhodium left over. You know, gotta post something on Reddit to flex it. You know, look at my fucking rhodium specs. Hell yeah. Now what we're doing is we're going to precipitate out rhodium hydroxide, well, hopefully, by just pouring this into some water. We'll pour it into some ice water because this is still concentrated sulfuric acid. We should see the rhodium hydroxide precipitate out. I think it will be kind of an awful yellow, maybe a browny colour, so it should be quite a distinct colour change, maybe. Give this another couple of minutes to cool down, though, because that's still 60, 70 degree sulfuric acid, concentrated sulfuric acid into water. Yeah, it should at least be room temperature. Alright, we definitely got the colour change we wanted, but that's all we got. Typical yellow chemistry, it's fine. The whole point of doing this was that the rhodium hydroxide is insoluble. Well, I thought so, and then that would precipitate out. We could either filter it off, or there's probably such a low amount, let it settle, decant off the solution, and collect the rhodium hydroxide. But yeah, it doesn't look like anything's actually precipitated out. Whether it's just such a small amount and such fine particles, it's kind of formed a perfect suspension of it. It's also hard to get this stuff off. I had the same problem with the niobium synthesis, which I tried to blowtorch and then shattered the flask. So I will try and learn from my mistakes and won't do that. The whole point of doing the lump of rhodium was that we would dissolve the lump, but it definitely looks like either the stir bar has broken up the lump into little pieces there, or maybe it's just chemically fallen apart. So anyway, I'm not entirely sure what to do, but I might just start neutralizing this solution a little. Just going to start putting in some, I don't know, sodium hydroxide, sodium carbonate, slowly. You don't want to foam it over or inhale lots of aerosoled rhodium, although I'd probably be the first person on the planet to get rhodium poisoning, but... Alright, we're here a couple of days later, and yes, the yellow colour still persists, but we do have some settling out. A little bit of solid. Let's give it a spin. Hold on, have we got any power? No. If I spin this, yeah, that'll stir it all up again, but there's definitely solid in there, which is what we want. We want the rhodium hydroxide. I was thinking the reason nothing has settled out previously is just because we hadn't dissolved enough rhodium. I don't know how strong the coloration would be, but there was a chance we'd only dissolved maybe a few milligrams, less than 10 milligrams, and maybe that was causing the coloration, but nothing to settle out. However, if we actually get our bead out, let's get our bead out. Here we go. We'll turn this on. Look, there's a little bit of rhodium, like metal shavings. There's a little bit here, but not too much. And we put this on here. Yeah, look, we've lost just over 100 milligrams compared to what the bead was before, and there's definitely not 100 milligrams in here. A little bit of rhodium powder, but you know, there's probably only 10 milligrams or so. Yeah, we have actually dissolved an appreciable amount. It's not like we've only dissolved 10 milligrams. We've dissolved about 100 milligrams into solutions. I think a lot of it is probably still stuck in this red stain here, which I can't seem to get off. So yeah, and maybe the neutralizing of the acid was a worthwhile thing. I think we're still acidic. You need so much sodium hydroxide to neutralize like the 20 mils of concentrated sulfuric acid. But yeah, look, we're still really acidic. So maybe I'll keep adding more sodium hydroxide. Once we get to like a neutral or a slightly basic pH, then maybe this yellow color won't be stable and everything will precipitate out as the hydroxide. And then we can think about how we also get that red stain off, because we want that red, that's rhodium. We want to dissolve that up and add that to our measly little bits of powder here at the bottom. That's what we want. Hell yeah, we've done it. It took me a long while. I was very frustrated for quite a while why we weren't getting any precipitate. I was stressing about it. I was concerned. I managed to get this much little bit of product, which kind of separated out, but nothing else was really settling out. I was a bit surprised by this, but yeah, and any excess alkali and the rhodium hydroxide redissolves, and if it's slightly acidic, the rhodium hydroxide redissolves. So we ended up at a pH of about... Yeah, alright, so still pretty basic, but not like purple, you know, that's like it's really like an 8. Maybe I just shouldn't have used sodium hydroxide, I should use something like sodium bicarbonate, which is not so basic. We've learned for next time I want to run rhodium chemistry. Look, we got some product down the bottom, that's what we're talking about. I really want to wash it, so I'll just pour off the solution, put in some distilled water, mix it around, let it settle, pour it off again, and then I'll start washing it with ethanol, because the next step is to put the rhodium hydroxide in with some acetic acid, glacial acetic acid, and some ethanol. So rather than trying to dry it all out and handle the dry powder, I think if we can just get it to a stage where it's kind of like we've washed all the water out with ethanol, then I'll be happy. And hopefully it'll settle a little easier on ethanol, because the ethanol's like a bit less dense maybe, and a bit less viscous maybe. I'm being hopeful here because this took a long time to settle out. It's only settled out this well because it's been here for 3 days or so. Yeah, so if I have to wait 3 days every time I want to do a washing, we're not going to get very far, but hopefully things improve. Oh, and I did get the stain off, yeah, because the knowledge of the fact that it was redissolving in excess hydroxide meant I could just reflux excess hydroxide in here in this flask with the big stain on it, and then the stain kind of came off. Well, we actually extracted that rhodium from the stain. We didn't get to throw that away because I think there was quite a bit of rhodium in there overall. So everything's all together now. Alrighty, we have our rhodium suspended in ethanol there. So I washed it a couple times with water and then a couple times with ethanol. We had to wash it with water first to get rid of the sodium sulfate that was dissolved in the water because it's not soluble in the ethanol. So if we just added ethanol straight away, it would have precipitated out all the sodium sulfate. So that's our big washing mixture there. We didn't lose too much rhodium, a little bit of rhodium, but it's fine. So this is ethanol, which is great. That's what we want. We're going to reflux it now with some acetic acid and some sodium acetate. Once again, this has been a real garbage tier video in terms of the chemicals used. But I think our acetic acid is still good. It's glacial acetic acid. The label's gone mouldy, which is always great to see. But hey, hopefully the insides are still good. I can't imagine 90% acetic acid goes mouldy, but you never know. And this is sodium acetate. It is a trihydrate. A little bit of water won't harm it too much. We're just using a tiny pinch of sodium acetate, so I'm not going to waste time making anhydrous and then adding it in and whatever. And if it all screws up, then it's all my own fault, which is fine. I can cope. Let's assemble all together. So we want to reflux it. Rhodium, is slow. Rhodium's slow to kind of like do the chemistry, so we will have to reflux it for a little while. We're once again expecting a reasonable color change. I think it might go green with a blue precipitate. Once again, a good indicator of it's actually working once we start getting sort of maybe a blue precipitate, maybe a green precipitate. I mean, it's a bit complicated just because you've kind of got we're forming an adduct with ethanol. We could be forming the tetraacetate and then getting that as a solid and collecting it and then forming the adduct with the ethanol. But instead, we're just going to try and do it all in one step. I think it should work, and then we should be able to use this solution directly for the rhodium rainbow. Yeah, I think that should be okay. This whole video has been just making shit up. It's fine. Let's go mix some chemicals. All right, the solution has just cooled down. Oh, it's been cooled down for a little bit. Just noticed it's kind of gone a different color again. Once it starts cooling down, well, once it's cooled down for a little bit, it kind of gets a bit of discoloration. I thought it would go more that blue color, which is this kind of blue ring we have around here, but kind of goes a bit browny once it cools down for a bit. Actually, I might just turn this condenser off. Where's it gone? No, not that one. This one. We are sort of ballpark around the concentration the paper uses as well, because the paper uses 2 milligrams per mil. We put 100 milligrams of rhodium in, probably just over 100 milligrams worth of complex. It's roughly 50 mils of liquid in there because that's a 100 ml flask and it's roughly half full. So it's 100 milligrams and 50 mils. We're roughly looking at 2 milligrams per mil, probably a little bit over, but I expected everything to dissolve a lot more nicer. What it probably is probably a lot of water in there. Remember I said a while ago, extra water in there shouldn't matter. It probably does matter. It's probably precipitating out a water complex instead of the ethanol one, but it's fine. I think it's fine just to use the water complex in this demonstration, which is starting from a green thing rather than a blue thing, but I think that's fine. Now, I've just been talking about this rhodium rainbow as this kind of weird concept and haven't actually explained what the demonstration is doing and like what the undergraduate practical is trying to teach. I don't want to weigh the video down with a lot of explanation, so I'm going to try to do this extremely quickly. So we're going to be adding in different ligands to those, the top and bottom of the complex, rather than the ethanol or the water, depending on what we have in here. As a different ligand comes in, for example, a pyridine ligand, those electrons from the pyridine are going to change the electrons within the rhodium complex, so it's going to change color. Not only have they bonded, but the actual energy levels inside the rhodium have changed because of that interaction. And this is going to be the case when we react this complex with, say, acetone. The electrons are also going to change, but they're not going to change in the same way because the geometry of those electrons that are interacting with the electrons in the rhodium complex are different between the acetone and the pyridine. And that's due to the shape of the interacting orbital. But that's enough talk. Let's find some chemicals. That's what we're wanting to do. We're having fun, we're hanging out, and we're fucking mixing some chemicals to make some colors. Alright, we've got some of our complex here. It is not a very nice color. We'll be adding roughly the same volume of acetone, and we're going to see what color it goes. Alright, I have a small amount of pyridine here. I hate to think what's happened to the rest of it. It's probably all just evaporated. And for this third one, we're going to be adding in some DMSO, which was another suggested reagent from the practical. The DMSO is in this brand new product from Bunnings, Ember Stripper. This was 50 bucks. I had to buy a whole litre anyway. So I imagine it works tremendously well. It is only 10 to 30% DMSO and 10 to 30% ethyl 3-ethoxypropanoate. Let's see if it goes the colour it's supposed to, as per the paper, as if it was actually pure DMSO and not just like a 10% solution from the fucking hardware store. Oh, that's thick. Lord, she thick. I should have suspected that. I always put fucking thickeners in. Oh, there we go. Go, 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 go. It's not exactly the rainbow as promised. I've got fuckloads more rhodium complex, so let's react it with other things in the lab and just see what sort of colours we get. Using hexamine, I got... Oh, sorry. Mate. What are you doing, little guy? Where do you want to go? What are you hoping to achieve here? What is your vision for this interaction? Have you got a web? You do. Well, no. This is with sulfamic acid, home descaler, and we've got hexamine. This is just in the form of fuel tablets. It's gone really quite red, even compared to the pyridine one. Okay, I diluted them in dichloromethane. It's still the worst rainbow you've probably ever seen. Kind of trying to be an orange, maybe to a yellow, then we move more into the red. That's it. That's yeah. I'm willing to say the most important thing is that we had fun, which is how you know I don't think the video went very well. But I can recover all this rhodium, so that's great, and recycle all this rhodium. I hope you enjoyed this video. I had a lot of fun. Anyway, I will see you in the next video, where we will probably once again do something simply for the fuck of it. That's what life's about, man. Just fuck me. All right.